What is service-oriented architecture, SOA? Service-oriented architecture, SOA, is a design approach in software development where applications are constructed by integrating independent, loosely coupled services. Each service in SOA is a distinct unit of functionality that can be accessed and reused by different applications, regardless of the platform or technology they use. The primary goal of SOA is to create a modular framework where services can be easily combined and reused, enabling businesses to be more agile and responsive to changes. Key concepts in SOA: services. In SOA, a service is a self-contained unit that performs a specific business function, such as processing payments, retrieving customer information, or managing orders. Services communicate with each other through well-defined interfaces, typically using protocols like HTTP or messaging queues. Loose coupling. Loose coupling refers to the minimal dependency between services in SOA. Each service operates independently, allowing for flexibility in development and deployment. Changes in one service do not require changes in others, making the system more adaptable to change. Interoperability. SOA promotes interoperability, which means that services can work together across different platforms and technologies. This is achieved through the use of standard communication protocols like SOAP, Simple Object Access Protocol, or REST, Representational State Transfer. Reusability. One of the main benefits of SOA is reusability. Since services are designed to be modular, they can be reused in multiple applications or business processes, reducing the time and cost of development. Each service in SOA has a service contract, which defines what the service does, the inputs and outputs, and the communication protocols it uses. This contract ensures that services can be used consistently across different applications. Discoverability. Services in SOA are designed to be discoverable. This means they are registered in a service registry, where other services or applications can find and use them. This helps in easily integrating new services or replacing existing ones without major disruptions. Scalability. SOA supports scalability by allowing services to be independently scaled. If a particular service experiences high demand, it can be scaled up without affecting the performance of other services. Real-life use case. E-commerce platform. Consider an e-commerce platform that uses SOA to manage its various business processes. The platform might have separate services for handling user authentication, product catalog management, payment processing, order fulfillment, and customer support. For instance, when a customer places an order, the e-commerce system can invoke several services: the payment service to process the payment, the inventory service to check product availability, and the shipping service to arrange delivery. Each service operates independently, but communicates with others to complete the transaction. If the business decides to introduce a new payment method, it only needs to update or add the payment service without changing the rest of the system. Benefits of SOA. Flexibility. SOA allows businesses to adapt quickly to changes by simply adding or modifying services rather than overhauling entire applications. This is particularly useful in dynamic industries where new features and updates are frequently needed. Cost efficiency. By reusing existing services across multiple applications, businesses can save on development costs and reduce the time it takes to bring new products or features to market. Improved collaboration. SOA promotes collaboration between different teams within an organization. For example, one team can develop a service for customer management, while another team focuses on order processing. These services can then be integrated seamlessly, ensuring that the final product meets business needs. Challenges of SOA. Complexity. Implementing SOA can be complex, especially in large organizations with many services. Managing the dependencies, ensuring security, and maintaining performance across multiple services require careful planning and robust infrastructure. Performance overhead. Since services in SOA communicate over a network, there can be a performance overhead due to the latency and the need for additional data serialization, deserialization. Security. Ensuring the security of each service and the data they handle can be challenging. Services need to be designed with robust authentication and authorization mechanisms to prevent unauthorized access. Real-life example: banking systems. Many banking systems use SOA to manage different aspects of their operations. For instance, a bank might have services for account management, loan processing, transaction handling, and fraud detection. Each service operates independently but can be combined to create a seamless banking experience. When a customer applies for a loan, the bank system can use the account management service to verify the customer's details, the loan processing service to calculate loan eligibility, and the fraud detection service to assess any risks. If a new regulation requires changes to the loan processing service, the bank can update that service without disrupting other operations. Conclusion: service oriented architecture is a powerful approach for building flexible, scalable, and reusable software systems. By focusing on services that are loosely coupled, interoperable, and reusable, SOA enables businesses to respond quickly to changes, reduce costs, and improve collaboration across teams. However, implementing SOA requires careful consideration of complexity, performance, and security to ensure that the system functions smoothly and efficiently.